we have two strings over a pulley and a bunch of paper clips hanging from each side of the pulley, and a spool of thread spool, to indicate more clearly on the video the position of the system. Now, we have equal numbers of, we have large paper clips and small paper clips on each side. And we have what should be equal numbers. Looks like we have one more on this side than we do on this side. Anyhow, no, actually we've got a big one here. Okay, we have equal numbers of large paper clips on both sides. And let me just reposition this one. Kind of wiggling around on me there. Okay. Equal numbers of large paper clips on both sides. We also have small paper clips. You might be able to see them, you might not. But I have a number on this side, a number on this side. Right now the number on this side, the number of small clips on this side, is greater than the number on this side. So there's more weight on this side than there is on this side. So if I release the system, it has some tendency to accelerate in what would be the clockwise direction. If you trace the string around the pulley, you have a clockwise motion. If I try to move it in the counterclockwise direction, it'll come to rest and tend to reverse its motion. You'll notice maybe that the pulley isn't completely smooth. Now if I transfer one clip from this side to this side, you see that there's maybe less tendency for the system to move in the clockwise direction, but it still has somewhat of a tendency to do so. If I move another clip, small clip, there doesn't appear to be much tendency for the system to move in the clockwise direction. Now I'm going to move a couple more clips. If I can get the things to come loose. Come on. I don't know what's going on with that one. Let's try this one. Okay, two more clips. I notice that I've now moved total of, I believe, 4 clips you can count. And kind of a bad spot on the pulley there, but you see that there's no tendency to move in this direction, the clockwise direction, but there is maybe some tendency to move in the counterclockwise direction. If I start the thing in the clockwise direction, it doesn't get very far. If I start it in the counterclockwise direction, what is going on there? Okay, counterclockwise direction. It tends to come to rest, but a lot more slowly than before. Now let's move another one, see what happens. Not a lot of tendency in this direction, whereas if we start it in this direction, it tends to keep going. Now if I was to move it down here and release it, depending on where I release it, it might actually turn around and come back up, but not quite. So I'm going to try to move another one. Here we go. Let's see what happens. There we appear to have some acceleration in the counterclockwise direction. I'll observe a couple of things about the system. In the first place, the total mass of the system is always the same. I'm transferring clips from one side to the other. Both sides of the system are being accelerated, and the total mass of the system remains constant. So what we're looking at is we're going to look at Newton's second law as it applies to this system. Another thing is what was preventing the system from accelerating in one direction or the other as we transferred several clips? Well, that was the friction in the pulley. And the pulley's an imperfect pulley. We could do this with a really good pulley, but I believe you'll be doing that in lab with a really good pulley. So we're just trying to get an idea of how the system behaves right now and get just a little bit of quantitative data, which we'll start in the next clip.